Hi. Today I'd love to introduce you to some of Moderne's new advanced features around impact analysis and how they relate to automated code remediation. So let's start with something really top of mind, vulnerability management. Moderne is introducing automated vulnerability remediation. We can run this recipe that identifies vulnerabilities by matching what Moderne already knows about the dependency footprint and matching them against vulnerability databases. We suggest fixes that are known safe. In this case, updating this property closes a high severity vulnerability related to privilege escalation. In addition to suggesting safe fixes, this recipe will also produce a data table of known vulnerabilities. Recipes can emit rows of tabular data according to simple schemas that they define, and Moderne aggregates rows across any number of repositories. We present that aggregate data for you to view. In this case, we're going to export it as Excel, so it's easy to integrate into data analytics tools you already use. And this Excel spreadsheet contains the rows, the vulnerability rows, from all of these repositories that we ran on. We've downloaded it. We can just open it up. And what you see is the columns that the recipe defined. We get to see the repository that was actually vulnerable, the CVE number, the version and its minimum fix version, a summary of the CVE, its severity, whether or not it was a direct or transitive dependency. And if we were, again, trying to think about automated remediation, we can use this data source as a way of prioritizing our action. Let's just look at Jackson, for example. In this particular set of repositories, a lot of these require minor version bumps. So we know that that's going to require both dependency and code changes, potentially. But a few of these are just patch release bumps. So we have a recipe that can automate that fix, and let's just close those. Those were the suggestions we made. So let's show a framework version that requires code changes in addition to dependency version bumps. Let's do something pretty extreme, like Spring Boot 3. From Spring Boot 2 version. We have a recipe for Spring Boot 3 that is deeply composite. It includes a lot of steps. We can look at it. To migrate to Spring Boot 3, you first have to migrate to Spring Boot 2.7, to 2.6, to 2.5, to 2.4. You'd have to update the tests from JUnit 4 to 5. All of these things, each of these little migrations takes a number of different steps, so this recipe is deeply hierarchical. You have to migrate to Java 17, which means you have to migrate to Java 11 first if you haven't yet. All of these steps are kind of going together. And we'll see how this relates to data tables as well. We're going to run this on a set of repositories. And of course, it's going to make the code, or it's going to suggest the code changes to you, so you could mass commit it across all of these repositories. But additionally, we'll output data about which little pieces of the recipe made changes, so that you can go back with the data table and look at what were the most common changes, what were the greatest areas of impact in this particular thing. Rather than downloading as Excel, we're going to show how we've integrated Jupyter notebooks in this case to take that Excel data and render it using a visualization that helps us understand. So we're running it here. We're going to produce what's called a Sankey diagram, which shows the constituent parts of this recipe and what were the most common changes that were made. You can see the most common change is to use this new instance of pattern match syntax that's available in Java 17. But we made some changes to ensure tests are not public, changing annotations, upgrading the Java version. So a lot of different kinds of things had to happen. look at another example, which is trying to find the third-party licenses in use. Common question that we get in compliance audits. So we're just going to look at all the licenses that we're using, all the POMs and the third-party dependencies of all the repositories that we're running against. And here again, we can download this as a data table. I'm just trying to show the variety of different questions you can ask of the source code. We've looked at vulnerabilities, we've looked at the recipes that made changes. In this case, we're looking at the licenses that are in use. Maybe let's just filter this one down to GPL and LGPL dependencies that are in use. And what we're going to see in this case is that they all have the GPL with class path exception, so it's fine, but that's the kind of question that we could ask here. This last one's pretty exciting to me because we're going to be able to show method usages. So let's look for all usages of REST template, any method name, any number of arguments. And what we're going to see in the data table that's produced, we can actually emit the code sample, the little piece of code that actually made a call to REST template. If we look at one of the results in the diff, we'll see in this case there's a constructor call to REST template, but there could be other API calls to it. If we look at the data table, again, we have a table called method calls. We're going to just download this as Excel. And one of the columns is just the sample of code that made that call. So you see a couple examples of the constructor call, just like we saw when we clicked on one of the diffs, a get entity call, some exchange calls. This just helps us to understand how an API is used. I'm really excited about this one because it kind of unlocks the ability to do classification type studies. And in a subsequent video, I'll show you how we're starting to apply large language models to not do the edit so much, but to detect similarity between usages of APIs and other components to perform classification and really try to wrap your mind around how a code base is structured. That's all for now. Thanks for listening.